We now look at properties of matter. What's the matter? This chapter we're looking at what properties of matter are. And first, though, we need to know what the definition of matter is. Now, matter is anything that has mass or takes up space. So if something has mass or takes up space, it matters. My grandpa Joe used to say to me, "Mr. Barron, you don't matter." I say, "Grandpa Joe, hey, I have mass and I take up space, so I matter." Now you matter, students. You do matter. No matter what anyone says, you matter, but really only because you have mass and you take up space. Now let's first look at intensive versus extensive properties so we can better understand properties of matter. Extensive properties will depend on the amount of matter in a sample. So if you have volume and mass, those are examples of extensive properties. Intensive properties will depend on the type of matter. Properties don't change no matter the size or the amount. So examples of intensive properties would be density, color, boiling point, etc. Okay, so an example of extensive properties, or something to explain that, we could have a different extensive properties here. We have half a liter of water versus a drop of water. Those are extensive properties. So volume, a drop versus half a liter, or we can say mass. I have 500 grams of water versus 1 gram of water. Now if I have this weight, a mass here is 5 kilograms versus a mass that I know some of my students have bench pressed, 500 kilograms. It's the same thing, but it's just a different mass. So you're still pumping iron, you're still lifting the steel, but it's still the same thing, but it just differs in how much, and that's an extensive property. Intensive, the properties don't change no matter the size or the amount. So for instance, density, color, boiling point, etc., those are intensive properties, like internal properties. So we have an internal property of paper, for instance. This piece is the same as properties of the whole piece. Or it doesn't matter the mass of this water, it still has the same internal properties, whether it's a drop or half a liter. It still is water, still does the same thing. The color, it's still going to be red whether I have a cup of this or just a little sliver of it. Water will still have the same boiling point no matter if I have a gallon of it or half a cup. Properties of matter, these are different properties of matter, and there are many others. Density, how dense something is, the temperature, what temperature it's at, the volume, how much space it takes up, the mass, how much matter it has, the speed it might be traveling, the state, is it solid, liquid, gas, the color, red, blue, green. Does it conduct electricity? That's electrical conductivity. Does it conduct heat? What's the melting point? What's the boiling point? At what point will it melt? At what point will it go into a vapor or gas? At what point does it boil? Malleability, is it malleable? Can it be smashed like a piece of clay? Is it ductile? Can it be drawn into some wire? So these are some of the many properties of matter. So the first thing we're going to talk about is the states of matter. And this state of matter is a solid. Now the solid, as you can tell and you probably know, it has a definite shape. So the shape doesn't change. It is what it is. Okay, here, I mean, I could change this, but I'm not going to. But most people just couldn't change the shape. It's solid. It has a definite volume. It takes up a definite amount of space. It's not easily compressed. You guys could squeeze it and I could put stuff on top of it, but it's not going to really easily get compressed, except I could. Now molecules inside, if we look at inside, they're really held very close together and there's very little movement between them. Yes, even though this is solid and it's just sitting here, there is movement between the molecules. There's movement in those atoms. But it's very little as compared to liquids or gases. Now liquids have an indefinite shape, so I could change the shape of this, and it's indefinite here. But it does have a definite volume. Okay, it's still half a liter about. No matter what, if I put it in, no matter what shape, I could put it in this water bottle, I could put it in this cup. It's still just going to be a definite volume of half a liter. Now it's not easily compressed. Now you may think so. You may think you can squeeze it or compress it, but you really can't. You can't just squeeze it. It'll go on top of you. But if you had liquid and you just tried to squeeze it, it's really not compressible because those bonds aren't really going to go anywhere. Now the atoms and molecules inside here have more space between them than a solid, but much less than a gas. It is more fluid than a liquid. Okay, it's fluid. There's fluidity there. Now a gas, such as the air we breathe, has an indefinite shape. There's no shape to it. An indefinite volume. So I can change the volume here of gas. Squeeze it, and comes out. Thus it's easily compressed. I can easily squeeze it. Now the molecules are moving in random patterns back and forth, varying amounts of distance between the particles. And they're moving very quickly, especially compared to a liquid or solid. The solids, the movement, there's still movement in solids, but it's just not as much as, for instance, in liquids or a gas. They're much more compact. They're held together in tighter bonds. And notice the temperature. There's more kinetic energy in the gas, so that there's more temperature. There's a higher temperature. They're moving around much quicker, much faster. There's much more energy there. There's much more collisions. There's no bonds between them compared to the liquid or the solid phases. Here's another view of translational motion. Quite interesting. You could have quite a enjoyable time just watching this. I know I can just stare at this for hours. Watch the collisions of the gas molecules. Now a chemical property is a property of an element or compound in the chemical reaction changes. Now all matter, no matter what, regardless of state, will undergo physical and chemical changes. Now these changes can be on a very small scale, atomic scale, which we'll never even see, or macroscopic, something huge that we can see with very easily. Now, the first type would be physical change. The substances that are not altered chemically, but merely changed to another form or phase. Okay, so you don't change what it is. It just changes the shape or to another phase. I.e., you might go from a liquid to a solid, such as freezing, or a liquid to a gas, such as boiling. You could separate it or combined. So it's still the same thing, you're just changing what it might look like. Now you can have reversible or irreversible. So example, water freezing into ice. You have water here and it freezes into an ice cube. You cut a piece of wood. Form or appearance has changed, but the properties of that substance are the same. Right? It has the same melting point, boiling point, chemical compositions. It's exactly the same. Water, no matter if it's ice or liquid or vapor, it's still water. The wood, it could be sawdust, but it's still wood. I mean, it's still, no matter what size, whatever you do to it, if it's a physical change, you still have the same thing. Okay, so let's look at examples of some physical changes. Now, before we do that, always wear your goggles. Here is a physical change. We have paper. And we are going to rip it. Physical change, pretty exciting. It's still paper, that's why it's a physical change. We could change it, crumple it up, we change it physically, but it's still paper, so it's a physical change. Another thing, we have ice here. Now we take that piece of ice, it's solid water, and look at that, we can change it to liquid water. It's still water, so it's a physical change.